Hello, friends. How y'all enjoying the show? All right, my name is Vinny Da Silva, and I'm a developer relations engineer working on Android XR. Now, before we began building XR headsets and AI glasses, before a lot of you even had like powerful rigs for your VR headsets, Qualcomm was making really deep investments in mobile augmented reality as far back as 2011. Qualcomm built Vuforia, one of the very first augmented reality SDKs for developers using advanced computer vision algorithms. And a lot of the features that we see today in XR devices, like inside-out tracking, can be traced back to these early days and these early investments where computer scientists were trying to figure out how to blend digital content with the real world. Representing Qualcomm today, we have Simon Steiner, a deeply technical product manager working on engine integrations and OpenXR. Please give Simon a warm welcome as he takes you on the journey from Snapdragon Spaces to Android XR.
Thanks. Hi, everyone. Thanks for the kind introduction, Vinny. I'm Simon, technical product manager for XR at Qualcomm, focusing on engine integration and OpenXR. The partnership between Qualcomm and Android started on phones, moved to foldables, to wearables, smartwatches. With Android XR, this partnership is now coming to XR headsets, XR glasses, and AI glasses, breaking the barriers of what's possible in XR today. Many of you might know this. Maybe that's why you're here, I hope. We used to develop our own XR platform called Snapdragon Spaces, which had a focus on enterprise applications. We created Snapdragon Spaces as an OpenXR-based platform that fills a gap in the XR industry. The same software on a range of hardware vendors' devices. For the very longest time, it used to be one platform, one device, or one line of devices. With Spaces, it became one software stack and N devices, a lot of them. Now that Android XR is here and sharing the same sentiment, we put all of our efforts into supporting Google with Android XR. This talk is about our efforts of transitioning the Snapdragon Spaces SDK over to Android XR. And it's not just interesting for former Snapdragon Spaces developers, but for anyone who has pain points with migration and cross-platform support. What's the problem at the core here? You want to reach as many customers as possible with your applications. You want to meet your users where they are at. A big potential customer is using Galaxy XR. That's great. You think about supporting Galaxy XR and Android XR with your applications, but you don't want to forget about your existing customers either and want to meet them on the devices that they are using. What are the challenges here? Fragmentation of the OpenXR platform on third-party specific vendor plugins can be at the core of these problems. Vendor plugins may cause incompatibilities. Different platforms require different versions of the engine, have different input, system, or perception features. And even third-party packages can be at the core of your problems if they aren't compatible with the platform you're using. Take, for example, XR MSFT controller model, a vendor extension that automatically gets you the right controller model on each device that you're using. Generally, a great idea, right? In fact, this was only used on one platform, HoloLens. If this were available on more platforms and more devices, it would be great. And this is exactly what's happening with XR EXT interaction render model, a new extension in the OpenXR standard. It just takes time to go from vendor extension to becoming part of the standard. As long as the runtime and extension set on a platform follow the standard, migration and cross-platform support are quite easy. Unity is the leading game engine for immersive XR experiences. Why is that? I think it's because Unity softens the problem of the OpenXR standard fragmentation. Firstly, they support the OpenXR standard with their OpenXR plugin. And secondly, they add another layer of abstraction on top of vendor extensions with AR Foundation, XR Interaction Toolkit, and XR Hands. They do magnificent work hiding the fragmentation of vendors underneath. You could say that OpenXR and Unity have a common goal here, reducing the standard fragmentation and making it easier for you, the developers, to support cross-platform and to migrate to new platforms such as Android XR. Qualcomm too shares the sentiment, and I believe that you as developers care about this deeply as well. Vendor-specific plugins for Unity are the second part here. They often bring custom additions and deviate from established AR Foundation APIs. And virtually every platform has one. Snapdragon Spaces was no exception here. We had OpenXR vendor extensions, and we had our Snapdragon Spaces SDK for Unity. The platforms, of course, they want to have something unique. They want to stand out, and it makes sense. They want to differentiate, but also later standardize their additions. Again, just like for the MSFT controller model, it takes time. Qualcomm is now contributing to the OpenXR working group to standardize our unique extensions and to help shape the new standard. But what is Qualcomm doing on the Unity side? We want to acknowledge the efforts that developers have put into bringing their applications to Snapdragon Spaces in the past 3 years. And the system with bringing those applications to Android XR now, regardless of the unique challenges that our additions to the Unity SDK for Spaces may pose regarding portability and migration. Earlier this year at Augmented World Expo, we unveiled the Snapdragon Spaces Compatibility plugin for Unity that supports easy migration from Snapdragon Spaces to Android XR. One of the developers that we worked with to prove this concept and who easily brought their application over from Snapdragon Spaces to Android XR is Sphere. Firstly, you can see Sphere running on a Snapdragon Spaces powered device. And then secondly, on Galaxy XR powered by Android XR. Sphere has integrated the SCP short for Spaces Compatibility plugin. But what has actually changed from Snapdragon Spaces SDK to the compatibility plugin under the hood? Our vision with Snapdragon Spaces was always to create an XR platform that can scale the XR ecosystem across many devices. Android XR is now that platform. How did we migrate to it? One of the first steps is that the custom APIs that we had in Snapdragon Spaces now move to standardized Unity and Android XR APIs. Or Qualcomm hand tracking, for example, QCHDI, now is replaced by XR Hands and XR Interaction Toolkit. The Spaces composition layers got replaced with XR composition layers provided by Unity. The Spaces persistent anchors, as of AR Foundation 6, are now available in the Unity's provided AR Foundation package. Spaces QR code tracking is now available via AR Foundation image tracking on Android XR devices. What is the result of those APIs moving? You can build the intersection of supported features from both platforms, Snapdragon Spaces and Android XR, via the compatibility plugin from the same project files and from the exact same Unity project. To assist with any other compatibilities aside from APIs that have moved, we built a specialized tool, the compatibility tool, in the engine that helps you maintain and migrate your project. Manual migration may have many steps and dependencies. We created this tool to keep track of the dependencies, compatible and incompatible features, and allowing developers to easily migrate and maintain cross-platform support. How can you access this? Firstly, you need a Snapdragon Spaces-based project. And if you then go to your packages folder and replace the Snapdragon Spaces package with the SCP package, you can find the compatibility tool in the project settings in the editor. It has 3 steps. First, you select your target platform. Do you want to build for Android XR or Snapdragon Spaces? Secondly, you go through the setup guide, which is basically an assisted version of the getting started documentation right in the editor. And then third, you have a bunch of validation steps for your currently open scene, for your player settings, and for your OpenXR settings that make sure that you are migrating correctly and your project is going to compile and work well on Android XR. One thing that already happens in the background when you select Android XR as a build platform is that the SCP is automatically adding a scripting defined symbol called using Android XR. Using those scripting defined symbols can be a powerful tool to keep code separate based on what platform you're targeting right now. An example, in the SCP, we're using this to automatically use the right controller model, depending on if you're targeting Snapdragon Spaces with a ring-based controller or Android XR with a ring-less Galaxy XR controller. And it all happens automatically, just because the scripting define is switched in the background. And if you now combine scripting defines with the new Unity build profiles, that's an even better path to keeping things running across platforms needed. One thing I'd love to do in the future is compile assemblies and assembly definitions with Unity build profiles, because that's going to make it even easier to keep everything neat and tidy across platforms. Right, getting to the next part in the compatibility tool, the setup guide. One of the first decision points when migrating, not just from Snapdragon Spaces, but from any other platform to Android XR is, what packages do I actually need? And it depends. If you're good with Unity-provided system and perception features, you should be using OpenXR Android XR, the standard package. If you want to have some more advanced features, such as body tracking or QR code tracking, you can use the Android XR extensions for Unity. To have the broadest compatibility of features between Snapdragon Spaces and Android, this package is required as well. If you have a lot of text in UI that needs to be well readable, you should be using XR composition layers. You probably also want to consider using XR Interaction Toolkit and XR Hands, as they are the primary input method for Galaxy XR. And then lastly, if you have your project built on built-in render pipeline, you should probably consider upgrading it to universal render pipeline, because for best performance on Galaxy XR, URP is very much recommended. All of these packages, since we moved the APIs over from Spaces, are supported on Android XR and Spaces now, and you can build from one single project. As a next step, the compatibility tool tells you to enable the OpenXR plugins for Spaces or Android XR, and then optionally you can import the SCP samples. Those samples, again, they are not the standard Android XR samples that you might have seen already. These are samples that allow you to build for Spaces and Android XR from the same project files. So a good example to see how you could do cross-platform compatibility. The next step in the setup guide is to optionally enable all of the features on the currently chosen platform. What is the maximum number of features that you can support across platforms with the least amount of effort? We tell you right there. In the compatibility tool, it lists all of the features in OpenXR that are compatible with both platforms right away. Coming to the validation steps. Project settings validation checks the player settings for any incompatibilities. Different devices, for example, may have different controllers coming with different input profiles. You're already recognizing that I like taking controllers as my example. Especially if you have an open platform such as Android XR and Snapdragon Spaces, where you might have a range of hardware vendors building their own controllers that look differently. You may encounter specialized input profiles. Once again, a deviation from the standard that makes cross-platform support a little bit more difficult. My tip here is to focus on the smallest common set of input actions. Focus on the smallest common denominator. It's always a good practice when you want to support cross-platform. In this case, it's quite easy. Snapdragon Spaces and Android XR support the Oculus Touch Controller profile. So just use this one, and you're going to be good to go. Then the next step in the validation is the scene validation, which checks your currently open scene for any incompatible components. This is especially useful when you're migrating to Android XR, because you might have your Spaces scene. It might use components that are not supported on Android XR. You just run this, and it's going to give you a list of everything that's incompatible. Also, secondly, keeping track of your scenes that have the same content but are built for different platforms can be tedious. And the more platforms you want to support, the more scenes you might have if you can't pack all of the same content into the same scene, and it duplicates work. With this tool, if you run it, it's going to tell you, is my scene going to build? Am I going to see a black screen? Hopefully not. But another validation step to ensure that developers have an easier time migrating and supporting cross-platform. And the last validation step is about OpenXR feature validation, which checks your OpenXR settings for incompatibilities. Earlier in the setup guide, we already had a list of features that supported on both platforms. You may choose to enable specialized features on either of the platforms that's not supported on the other. OpenXR feature validation adds another level of security here. If you run it before you do a build, it's going to tell you, is there anything that's going to cause me trouble later on? So it happened to me a bunch of times, for example, that I enabled one feature for one platform, then made a build, and it caused a black screen. I was wondering, what's actually going on here? And then, analyzing the log, I realized, oh, I might have enabled the wrong feature. All right. And this way, it's just a bunch of less time that you need to spend debugging on. You can avoid mistakes that don't need to be made. All right. Two examples for features that you want to look at when supporting cross-platform. Firstly, one where things are pretty simple, and secondly, one where things are getting a bit more harder. For meshing, if you look at it on Snapdragon Spaces and Android XR, you're going to find out that the basics still work out of the box. But some smaller things are different. In our foundation, you can always find optional features for each platform. It's worth taking a look at this. They have very great documentation for it, by the way. They updated this recently, which is kind of great. Yeah. Android XR here supports some more optional features than Snapdragon Spaces does. Both support normals, and then Android XR adds support for queue size and mesh classification. What would you want to do in this situation? For maximum cross-platform compatibility, you want to, again, support the smallest common denominator. In this case, just normals. If you build any logic or code around optional features such as queue size and classification, that's potentially going to cause you problems later when you want to support cross-platform or migrate to another platform. You make an informed decision about the features you're using when you're thinking about implementing features that use these. Right. Another example where things get a little bit more difficult between Snapdragon Spaces and Android XR is QR code tracking. Firstly, on Snapdragon Spaces, we built our custom AR Foundation style API. And on Android XR, it's using the established image tracking API with QR codes. So in Spaces, we have the Spaces QR code manager, and on Android XR, it's the image tracking AR Foundation API using the AR tracked image manager and reference image libraries. The optional features, again, are similar, but then again, also different. We have market tracking, we have size estimation on both, but then on Spaces, we have QR code versions, filters, and on Android XR, we have a maximum number of simultaneously tracked markers instead. What would you want to do in this situation? You would think twice about supporting both of them. And if you do, you would somehow need to build some logic around it, keep different scenes, use scripting defines to keep it separate. Good news, you don't have to, at least not for Snapdragon Spaces and Android XR. This is why in the SCP now we support the Android XR way of doing QR code tracking, the standardized way. Embracing the standard, reducing fragmentation, and making developers' lives easier. That's the goal here. If you are a former Snapdragon Spaces developer, we recently released version 1.0 of the Spaces Compatibility plugin on our Qualcomm Software Center. Oh, I'm standing in front of the QR code. Going to the side. It integrates all of the cross-platform and migration tooling that I presented to you today. You just need to log in, and then you can download it. Right. And me talking about spatial meshing and QR code tracking was also not a coincidence. These are the two features that we just added to this new version. All right. Then, coming to the second part of my presentation here today, that is hopefully a little bit surprising for you. I mentioned possibly incompatible third-party plugins for Android XR right in the beginning. And coming from Snapdragon Spaces, we know that a lot of developers are still using MRTK, some maybe even MRTK2 from HoloLens times. And there haven't been big news for a while. And some might even ask a question like this, is this dying on our GitHub page? Today, I can confirm MRTK is not dying, but it is evolving. MRTK has been a critical piece of XR dev history since its inception in 2016, and shifted and adapted through all major XR developments. HoloLens, Magic Leap, Spaces, Quest, and now, with the introduction of Android XR, MRTK evolves once again to bring support to this platform and welcomes all of its developers. What's new? MRTK now supports Unity 6. Unity 6, again, has dependencies to several other XR packages and versions. AR Foundation 6, XR Interaction Toolkit 3, both are supported. XR hence now serves as the joint provider, which improves flexibility on all supported platforms. For Android XR specifically, we added hand mesh rendering via Android XR hand mesh data, bringing you high-quality hand meshes. And lastly, MRTK has transitioned from the Microsoft Mixed Reality OpenXR plugin to the Unity's OpenXR plugin. Also, a common theme that you might see here is embracing Unity's broader XR ecosystem as the standard. The best way to get the latest packages of MRTK right now is on the GitHub releases page for MRTK 3. If you have used the Mixed Reality feature tool in the past as the way to get the packages, it's unfortunately been deprecated, but you can still replace your packages with the ones from GitHub if you look into your packages Mixed Reality folder and update your manifest as well, don't forget. All right, and then there's also documentation available to set up your project for Android XR and to migrate your project from using XR Interaction Toolkit 2 to XR Interaction Toolkit 3. And the documentation, by the way, has also moved to GitHub Pages, so new website for the documentation. And here's a video of MRTK running on Galaxy XR, using the established interactions and familiar input that you hopefully all love. Also even integrating some system functionality such as a keyboard. We went one step further than just supporting MRTK 3. We know that the update from MRTK 2 to MRTK 3 may not be worth it for all of you, and it takes time. So what we did is, that didn't work. Today we are announcing and releasing the MRTK 2 add-on for use with Android XR. What do you need for this to work? You need to have a project in Unity 6 using MRTK 2. And the MRTK packages must have been imported via the Mixed Reality feature tool, not as Unity packages, otherwise the add-on won't find them. Technical difficulties. Also important, you can go to the Qualcomm GitHub via this QR code that I'm once again standing in front of. This is on the Qualcomm GitHub, not the official MRTK 2 repository. Simply because the old MRTK 2 repository doesn't take new commits anymore. Right? If you add this package to your Unity project and follow the setup instructions in the repository and then the documentation hosted by the repository, you should be good to go to bring your MRTK 2 based project to Android XR right now. And once again, if you're building for MRTK, you should be using Universal Render Pipeline for best performance. And just watch out for your materials. If you use the standard MRTK shaders that come with MRTK, they don't simply upgrade using Unity's update tool. And you might end up looking, it might end up looking something like this, where you see a lot of magenta and shader errors. Luckily, MRTK does have its own upgrade tool in the menu item, upgrade MRTK standard shader for lightweight render pipeline. Right. In conclusion, Android XR is now the unified platform that delivers consistency and reliability, enabling developers to innovate and scale with confidence. We're excited to bring this vision to life with Galaxy XR and the next generation of white XR glasses. Thank you.